An ant is sitting in the middle of a circle of radius 3 meters. Every minute, the ant picks a random direction and moves in a straight line for 1 meter. We can simulate this scenario using tessellations. So on the left-hand side, you can see that we've overlaid a hexagon, and each of the lengths there are 1 meter. So there are 3 random directions that the ant can take in that simulation. To the right, we can see that we've used equilateral triangles, where each of the lengths of the triangle are 1 meter. And here you can see there's now 6 random directions that the ant can take in that simulation. So what we're going to do now is we're going to use a spinner to select one of 3 directions for the ant to travel along. If we want 3 directions, we're going to set our spinner up to each have 3 regions of equal area. And we can see that the first spinner has landed on the red. And if you could picture that spinner, that's pointing out towards this direction here. When we do our second spin, it's pointing towards the blue. And if you put your little spinner here, this sends us back to the original starting position after 2 spins. Next, we spin a blue again, and you can picture that that's this direction. And now we spin a 4th time, and we're going to spin another blue. And of these 3 directions, that's heading out there. The 5th spin is a red, so that sends us again back in this direction. Then we spin another red, and that red leads up here. Another red, and its direction is this one. And finally, the last one is also a red, which takes us finally to the edge of the 3 meter radius. Therefore, it takes the ant 8 minutes to leave the circle. So we'll do another one of those again. So this time, our first spin is blue. So that's this direction. The next spin is red. So if you have a look here, the red direction would be along this path. Then we have another red, which takes him to here. A green, which is this direction. Then we spin a red, which is this direction. And then we spin another green, which takes him here, which is the edge of the circle. So for the second simulation, it took the ant 6 minutes to leave the circle. So the simulation was run a few more times, and we've got 10 trials here. And an important note is, ideally we'd perform more than 10 trials, but we're keeping it simple for this instruction. So our first question asks, for the simulation using hexagons, what is the probability that the ant will take less than 10 minutes to exit the circle? So what we need to do is look at all of the trials that resulted in a time of less than 10 minutes. So we had an 8, a 6, and another 6 down here, and these are all the ones that are less than 10 minutes. So the probability that the time is less than 10 minutes is equal to 3 outcomes over 10 trials, which is 0.3 as an exact decimal. For part 2, we're asked what is the probability the ant will take more than 20 minutes to exit the circle. So more than 20 minutes is this 21 here and this 29 here. So because it says more than 20 minutes, we don't include the 20. So overall, the probability that it is more than 20 minutes is equal to 2 outcomes out of 10 trials, which is 0.2. Next, we're going to explore the same situation, but this time we're going to use our triangle tessellation. So instead of using a spinner, because there's 6 outcomes, we're going to roll a dice. So on our first roll, we get a 4, which is in this direction. Then we roll again and we get a 3, so this would be 1, 2, 3 would be in this direction. Then we roll and we get another 4, so that takes us to here. So we next roll and get a 2, which is in this direction. And then we get a 4, which is 1, 2, 3, and 4 is in this direction. So now the ant is outside of the circle. And that simulation, it took 5 minutes for the ant to exit the circle. So we'll do this again. And on our first roll, this time we get a 5. So we come out here. Then we get a 3, so that's 1, 2, 3 is in this direction. Then we get a 6, so the 6 actually takes us back up that path again. Then we get another 6, so we go out to here. Then there's a 5, so 5 is in this direction, so the ant's almost out. And then we get a 1, and 1 leads us up to here. And then we get a 5, which is this direction, and the ant is finally out. So for that simulation, it took 7 minutes for the ant to exit the circle. So once again, we've performed a few more simulations, and we've put them in the table here. And again, it's really important to note that when we simulate, we generally want more than 10 trials. But again, we're just keeping it simple for this video. So part B says using the simulation results of the triangles, we want to work out what the probability is that it will take the ant less than 10 minutes to exit the circle. So we have a 5, a 7, a 4, a 4, an 8, and a 5. So the probability that it takes less than 10 minutes is equal to 6 outcomes out of 10 trials, which is 0.6. So using the hexagons, that was only 0.3, and now it's up to 0.6. But if we did more trials, we'd get more accurate results and be able to better describe the probabilities involved in this simulation. For part 2, we're asked what the probability is that the ant will take more than 20 minutes to exit the circle. So this time there's only one outcome that's more than 20 minutes. So the probability that it is more than 20 minutes is equal to one outcome over 10, which is 0.1.